Hello, hello, my fellow stargazers and cosmic enthusiasts. Leonard here, your guide to the grandeur of the cosmos, welcoming you back to another episode on Universe 101. Today, we're going to delve into a fascinating conundrum that has been puzzling astronomers for years: the cosmic age problem. So buckle up, grab your telescopes, and let's embark on this cosmic journey together. Now, imagine you're trying to bake a cake, but you've lost the recipe. You know the ingredients: flour, eggs, sugar, and so on, but you don't know the exact quantities or the baking time. That's the situation astronomers find themselves in when trying to calculate the age of the universe. We know the ingredients: stars, galaxies, dark matter, and dark energy. But determining their exact proportions and how they've interacted over time is a monumental task. The primary method we use to estimate the age of the universe is by observing the oldest celestial objects we can find. It's like trying to guess the age of a tree by looking at its oldest branches. The oldest objects we've found so far are globular clusters, ancient groups of stars that orbit the outskirts of galaxies. By studying these clusters, we've estimated the universe to be around 13.8 billion years old. However, there's a catch. When we measure the rate at which the universe is expanding, a value known as the Hubble constant, and extrapolate backwards, we get a different age for the universe, closer to 12 billion years. It's like measuring the growth rings of our tree and finding out it should be younger than the oldest branch. This discrepancy is what we call the cosmic age problem. Now you might be thinking, Leonard, a couple of billion years, give or take, what's the big deal? Well, in the grand scheme of things, it might not seem like much, but in the world of cosmology, it's a huge deal. It's like finding out your cake should have been in the oven for 30 minutes, but the timer says it's been baking for 40 minutes. Something doesn't add up. So, how do we resolve this discrepancy? Well, there are a few possibilities. One is that our measurements are off. Maybe our telescopes aren't as accurate as we think, or perhaps there's some cosmic dust interfering with our observations. It's like finding out your oven's temperature is off, or there's a draft in your kitchen affecting the baking time. Another possibility is that our understanding of the universe is incomplete. Perhaps there are ingredients in our cosmic cake that we haven't discovered yet. Or maybe the universe isn't expanding at a constant rate. It's like realizing you forgot to add baking powder to your cake, or the oven temperature fluctuates over time. Before we wrap up, I want to remind you to hit that like button if you've enjoyed our cosmic journey today, and don't forget to subscribe to Universe 101 for more deep dives into the mysteries of the cosmos. Your support helps keep this channel going and allows us to continue exploring the universe together. In conclusion, the cosmic age problem is one of the most intriguing puzzles in astronomy. It challenges our understanding of the universe and pushes us to refine our methods and theories. But that's what makes astronomy so exciting. It's a never-ending quest for knowledge, a journey into the unknown. And who knows, maybe one day we'll finally figure out the perfect recipe for our cosmic cake. Until then, keep looking up, my fellow stargazers. Leonard signing off.